So continuing on, so now for today we're on law of sines and then law of cosine. So up here we have law of sines. So A over sine A equals B over sine B equals C over sine C. And so here we're now going to be talking about triangles that are not right triangles. So either acute or obtuse triangles. So for example, let's say we have a triangle where angle A is 127 degrees, side A is 12, and side B is 6. And I want to know what is the measure of angle B, what's the measure of angle C, and what's the length of side C. And so we can make use of the law of sines, so we would have 12 over the sine of 127 is going to equal 6 over the sine of B, and we're going to solve this for angle B. So first thing we're going to do is to solve our proportion. So we're going to have 12 times the sine of B is going to equal 6 times the sine of 127. We're going to divide by 12. We're going to solve. That is by 12. And so sine B, 6 sine 127 over 12. And we want to know what angle B is. And the way we find out what angle B will be the inverse sine of 6 sine 127 over 12. Right? And so we can plug all that into the calculator and get out an answer. And we'll find out that angle B is going to be 23.5 degrees. So now we can find the other angle in our triangle. Remember that angle A plus angle B plus angle C has to equal 180. And so we know the two, we can get the third. So we know this is 127. We now know this is 23.5. And so we can find angle C because we know the sum has to be 180. And so this will be 150.5. And so we can subtract. And we get that angle C, so C, is going to be 29.5 degrees. So that's the two angles, and so we now have left finding side C, and so we go back to using our law of sines. And so we got 12 over the sine of 127 is going to equal C over the sine of 29.5. And we're going to solve for C, so we're going to get 12 times the sine of 29.5 is going to equal the sine of 127 times C. The opposite of multiplying is to divide, so we'll divide by sine 127. Divide this by the sine of 127. And we end up that side C is going to be 7.4. Right? And so we have the measurements of our sides, we have the measurements of our angles in this triangle. Right? Okay. And so the way this will work is that the largest side will be opposite the largest angle, the smallest side will be opposite the smallest angle. Well, let's go through another one. And so now let's say that angle A is 31 degrees, angle B is 100 degrees, and side C is 35. Well, let's first off by finding angle C. That's the easy one, after all. I know these two, those add up to 131. We do a little bit of subtracting, we get angle C is going to be 49 degrees. Right? So now we need to find the missing sides, and so we have the A over the sine of 31 is going to equal use a lot of sines, we need to have what I call an angle-side pair, right? So we need to know a side and we need to know the angle opposite from it. So we now have that once we found what angle C was. So we can then cross multiply, so we're going to get A times the sine of 49 is going to equal 35 times the sine of 31. Divide. And so we get that side A, in this case, is going to be 23.9. And then we can do log sines again to find our other side. And so we have 35 over the sine of 49 is going to equal B over the sine of 100. We're going to solve this the same way we just solved this one. And so we're going to have B times the sine of 49 is going to equal 35 times the sine of 100. And again, divide by the sine of 49. Divide this by the sine of 49. And we end up that side B is going to be 45.7. So we got all the missing pieces in regards to our triangle. Right? And then one I'll just put up for you to think of, but in terms of this question, that would be if B is 60 degrees, angle B is 60 degrees, and side B is 10, and side C is 10. Should be able to think about that a little bit and be able to tell me pretty quickly what the other missing numbers are going to be in terms of given that scenario. Okay. But given a lot of sine questions, there is something that you have to take into account. That is if the opposite side is less than the adjacent side, then there's some things that could happen in terms of outcomes here. So if I have a start of a triangle, it looks like this, and I have that this piece over here is what we're going to be calling in terms of our opposite side. Okay. And then we have in terms of our adjacent sides. Okay. Then we have to worry about what is the height of this triangle, that perpendicular drop. Okay. So that's height. Okay. Because depending on what we have going on here, it could be that this doesn't reach to make a triangle, or it could actually make two triangles, depending on what happens, right? And so you have in terms of this. So if and that. Right? So if the height is greater than the opposite side, then there is no triangle possible. If the height is equal to the opposite side, then you have a right triangle. Or lastly, if the height is less than the opposite side, then you have two possible triangles. And let's go through an example as to how this all works. So, for example, given one like this, if angle A is 23 degrees, side A is 15, side B is 21, right? So here, this is my angle, this is my opposite side, this is my adjacent side. So my opposite is less than the adjacent. So the first thing I need to do is find the height. The height is given by adjacent sine theta. So we get 21 times the sine of 23, and this number comes out to be 8.2. And so this number is less than that, which means that tells me that there could be possibly two triangles. Now an idea as to how this works, right? So we have our piece here. We have our angle here, which is 23 degrees. This piece is 21, right? And then we have this side A, which is 15. So what happens is that this piece that's 15 could go where it's going like this, and we make a triangle, right? Because we know that our height is only 8.2. Right? So we know that the height, that this is 8.2. Right? Right? But if you think about this point here basically being a hinge, okay? I can make a triangle that looks like this, but I also could make a triangle where it's going like that. And so we have that there are two possible ways of making that triangle. Okay? And so we need to find out all the information in regards to both possible triangles. Right? So in terms of this process then, so let's first go what I will call case 1. And so the first thing I want to do is we're going to find angle B. So 15 over the sine of 23 is going to equal 21 over the sine of B. And we're going to basically, like we've seen before, we're going to cross multiply and find the inverse sine. So angle B is going to be the inverse sine of 21 sine 23 over 15, and we plug that in, and this will come out to be 33.2 degrees. Right? Okay. And then because we know two angles, we can find the third angle by subtracting from 180. And so angle C would then have to be 123.8 degrees. Right? So we got those two numbers. And now we need to find the measurement of side C. So we have 15 over the sine of 23 is going to equal C over the sine 123.8. Again, cross multiply divide. So 15 sine 123.8 over the sine of 23. And we get that side C comes out to be 31.9. So that is everything in regards to case 1. Now we got to go to case 2. Well, the given information is the given information actually for both triangles, right? And also the way it works is that in terms of that first angle which we found, which was B, is that this angle and then this angle here have to be supplementary, which means they have to equal 180. And so when we go to case 2, the new angle B is going to be 180 minus the 33.2. So that's going to be 146.8. And then the new angle C, again subtracting from 180. So we know this is now our new angle C. Our angle A is still what it was. And so this now comes up to be 10.2. Right? So we have those two numbers. And then it's a matter of finding the new side C. And so 15 over the sine of 23 is going to be C over the sine of 10.2. And again, cross multiply divide. So 15 sine 10.2 over the sine of 23. And we get that our new side C is going to be 6.8. So we have everything in regards to, right? So that is law of sines. So basically, in order to use law of sines, you have to have that angle side pair. So you gotta either know angle A side A, angle B side B, or angle C side C. Well, then you get to the other law, which is the law of cosines. Okay. And so we'll write up all three variations of C squared, A squared plus B squared, minus 2AB cosine of C, or B squared is A squared plus C squared, minus 2AC cosine of A, or A squared equals B squared, or C squared minus 2AC cosine of, sorry, this should be cosine of B, got ahead of myself, and then this should be cosine A, right? And so those are the variations of it, right? So basically this one we're going to use for when we either know all three sides or we know side angle side, right? So we'll go through the two cases. So let's say, for example, you do one first, you know, given three sides, right? So given side, 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 right? Right? Now in order to do this type of question, there are some rules that you have to apply. And so given side, 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 thou shalt find the angle opposite the largest side first. So you have to do this in the right order. Otherwise you get into that tricky scenario with the law of sine. So let's say I got these measurements. A is 11, B is 17, and C is 14. Well, my largest side is going to be side B. And so we would have that 17 squared is going to equal 11 squared plus 14 squared minus 2 times 11 times 14 cosine of B. So we'll start doing the math here. So this is going to give us 289, 121, 196. This is going to give us 308 times cosine of B. So we get 289. Add those two numbers together, we get 317. 8 cosine of B. So we're going to keep on working this, and we're going to solve for B. The next step is we need to bring 317 to the other side. So negative 28 equals a minus 308 cosine of B. And then the next step is we want to divide and take the inverse cosine. And so we have that negative 28 over negative 308, and we're going to do the inverse cosine of that. This is going to give us angle B. And so angle B ends up being 84.8 degrees. Right? Now it ends up in a log cosine question. We only have to use log cosine one time because now we do have an angle side pair. And so we can now find either one of our missing angles. And so now we can use law of sines. And so we would have 17 over the sine of 84.8 is going to equal 11 over the sine of A. And so we want to find angle A, and so angle A is going to be the inverse sine of 11 times the sine of 84.8 over 17. And you plug that in, you get way, we know that angle B is 84.8, and so we could find angle C, again, just by subtracting, and I'll leave that for you to do. So we got a lot of cosines when we have all three sides. The other scenario is if you have this, if you're given side angles, something, right? And then you have, in terms here, a couple of thou shalts. Thou shalts find the side opposite the given angle first. Find the side opposite the given angle first. So, for example, given something like this, given that angle C is 100 degrees, side A is 12, and side B is 20, right? So we want to find side C first, right? And so we would have that C squared is going to equal 12 squared plus 20 squared minus 2 times 12 times 20 cosine of 100. Right? Now in terms of on your calculator, you should be able to just say C is going to be the square root of all of that. Right? So you should be able to plug square root, plug all of that in there, and then just hit enter at the end, and you should be able to find out that side C is going to be 25. Right? Right. So we got thirds, so we got that side. Now there is a second thou shalt in this scenario, and so you got thou shalt number 2, and so now the next one is thou shalt find the angle opposite the shorter of the two given sides. And so in terms of this question then, we would have to find angle A, because we have that this is my smaller side, right? And so we have 25 over the side of 100 is going to equal 12 over the side of A, and so angle A is going to be the inverse sine of 12 sine 100 over 25, and you plug that in, and you get this will come out to be 28.2 degrees. Right? So we have our information in regards to our triangle. The other things talked about in this section for today will be on polar coordinates. So polar graph. So yeah, in terms of something that looks like this, let's make this smaller. So polar coordinates, right? So polar coordinates are given in terms of r and theta. So radius and that angle, right? So for example, if I wanted to plot the point 3, 60 degrees, and so this piece of paper is in degrees, and so if I have each one of these circles, so 1, 2, 3, and then 60 degrees, that point would be there, roughly, okay? And if I wanted to plot the point 3, negative 300, okay? Well, 3, negative 300, circle 3, go negative 300, it would also put you right there, okay? So it ends up that in polar, you can actually end up at the same spot multiple different ways. Right? And so I get in terms of being there. Right? Now, what happens if I wanted to grab the point? Let's do a color. So let's say I want to grab the point -2, 135 degrees. Right? So go out the circle radius 2, go to 135, but because we want the negative, we'd actually go across and would end up being down here, right? So the negative puts it on the opposite side, where you're negative r. Yeah. So we want to be able to convert back and forth from different coordinate systems. So if I want to convert from rectangular xy to polar, and so for example, let's say I have on a graph the point 3, 4. I want to know in terms of r, and I want to know in terms of theta, right? So the r value would be given by this, would be the hypotenuse. And here's my theta there, right? So we got that this is the x coordinate, this is the y coordinate. And it's a nice right triangle, and so we would have that x squared plus y squared is going to equal r squared, which means r is going to be the square root of x squared plus y squared. So that would give us the r value. And then the theta, well, this is opposite over adjacent, and so we would have that tan theta is going to equal y over x, or theta is going to be the inverse tangent of y over x. So let's do that in terms of this particular point. So r is going to be the square root of 3 squared plus 4 squared. So this is going to be the square root of 25, and so r is going to be 5. And then theta is going to be the inverse tangent of 4 over 3. And so my angle here comes out to be 53.1 degrees. And so my point would be 53.1 degrees. And that would be the corresponding point in polar form. And then if I want to go the other way, from polar to rectangular, we make use of these two formulas. And so x is given by r cosine theta, y is given by r sine theta. And so if I had the point by 53.1 degrees, and I want to convert that, I would have that the x value is going to be 5 times the cosine of 53.1, which will come out to be basically 3. And then my y value will be 5 times the sine of 53.1, given our rounding, will come out to be basically 4. And we would get the point that we started with, which is the point 3, 4. So in terms of these various formulas then that we'll make use of for between rectangular and polar, you got r equals the square root of x squared plus y squared. Okay, or r squared equals x squared plus y squared. Move up. You got x equals r cosine theta, y equals r sine theta, and then theta is the inverse tangent of y over x. So those are the formulas we had up before. And so we could have then, in terms of given an equation, converting an equation. So we want to convert this equation polar. So we got 4x plus 3y equals 12. That is an xy rectangular equation. I want to convert that to a polar equation. Well, x is given by r cosine theta, so it would be 4r cosine theta plus 3r sine theta equals 12. And generally, in terms of a polar equation, it'll be going to be terms of r equals something. So I can take an r out. And then divide both sides. This. And so we end up that r is going to be 12 over 4 cosine theta plus 3 sine theta. And so we convert our equation from an xy equation to an r theta equation. And then, well, lastly, in terms of polar graphs, right? Polar graphs can give you some very interesting patterns that occur. So, for example, let's say I wanted to graph this equation. R equals 3 cosine 2 theta. And we're going to make a chart in terms of thetas and r's. Right? And if we plug this in, we're going to do in terms of angles. We're going to go, I'm going to go by multiples of 30. So if I plug these into here and go and do our math here, we got that this will come out to be 3. We plug in 30. This comes out to be 1.5. This comes out to be negative 1.5. Negative 3. Negative 1.5. And then 1.5. And then 3. Okay? And then if I do basically the other side, my other chart, so now we're going to have 210, 240, 270, 300, 330, and then lastly 360. My pattern of numbers keeps continuing, and so I get negative 1.5, negative 1.5, 1.5. Let me see, I'm missing one. Oh, I am missing one. I'm off one here. Let me get this right. Right. So 240, sorry, this is 3, then negative 1.5, 1.5, and then 3. So there's my point. So I need to now put in my polar graph paper again. So I put that in. And I'm going to make this smaller. Just so I can put it here next to my charts. Right? So now we need the graph, right? So we got 0, 3. 1, 2, 3, that's going to put us here. We got 31.5, so that'll put us roughly here. We got 60, negative 1.5, so that's going to put us on the opposite side. So 60, negative 1.5 is going to put us here, roughly. 90, negative 3, so that'll put us down here. Right. 120, negative 1.5. 120, negative 1.5 is going to put us here. 150, 1.5 it'll put us here. 180 and 3 is going to put us up there. And then 210, 1.5 will put put us here. 240 negative 1.5 is gonna put us out over here. 270 negative 3 is gonna put us here. 300 negative 1.5 put us here. And then 330 1.5 is there, and then back in. And then we want to basically connect the dots, and what happens here, and it may be easier on a piece of paper than it is going to be me doing it here on this board, but given that these pen widths, you end up with something that is going to look like this. And like I said, it might be easier to draw on a piece of paper and a pen than it is here for me to do this on the board. But that will conclude